Okay, Unit 2. We're going to do a lot of math in this unit, measurements and calculations. You might want to have your calculator ready. You'll want to have a scientific calculator that you can use. So make sure that it has it has like a EXP button and a scientific notation button. It has a log button. You could probably find YouTube videos of how to use your particular calculator. And we'll talk about how to put exponential numbers in your calculator, but it's really hard to do each individual one. But anyway, you might want to stop this video at some point and try some of these calculations for yourself. All right, so measurements and measuring units. Well, the difference between chemistry and math is that chemistry uses math to measure things. So we can observe matter without measuring, but once you measure things, it expands our knowledge. So there are always two parts to a measurement, the number and a unit or label. So you need to get in the habit of always writing your label or your unit when you write numbers down. You know, for example, if I said that cup is 2, you might say, 2 what? Well, it could be 2 feet high, it could be 2 inches wide, it could be 2 years old, it could weigh 2 pounds. And so chemistry is applied math in that you really need to know what unit you're talking about. Measurements are units. Measurement units are agreed upon by those making the units, and we make measurements by using measuring devices. I'm sure this is something you already know. We can measure the length by using a ruler, the weight by using a balance or a scale, volume. And in the U.S., we use what we call the English system, but scientists pretty much all over the world and in most countries, even in their normal everyday life, they use the metric system, which the SI system actually gets used. The System International is what SI stands for, but it's based on metric units. All right, so the metric system is far superior to our English system because it's a decimal system, which means that all of the units are just factors of 10. You're dividing or multiplying by a factor of 10, so it's much simpler. The SI system, or the international system, units are a very slight variation on the metric system. And you can see the difference here. It's not anything that you really need to worry about. We're mainly just going to focus on the metric system. So we're going to do a little review of the metric system here. So length is always measured in meters. That's sort of the standard length unit. Just for your information, 1 meter is about 39.4 inches, so it's slightly longer than a yard. And then you may be familiar with centimeters or kilometers, so different types of measurements will use different varieties of the metric unit meter. Volume is considered the amount of space occupied by a substance, and so volumes are always measured in some kind of flask. If we're in the kitchen, you use your measuring cups. If we're in the lab, we use what's called graduated cylinders or various other glassware that's measured with marks on it. So the standard measurement of volume is the liter, and the liter is just slightly larger than a quart. Another common unit that might be used with volume is a milliliter. You're probably familiar with that. Okay, and then mass is a measure of weight or the quantity of material. We usually use some kind of scale. And the standard unit for mass is gram. You might also talk about kilograms if you have larger masses. You might also hear of milligrams. A lot of times medicines are in terms of milligrams or micrograms. We'll talk more about the different metric units in just a minute. Okay, scientific notation. So this is a way of indicating very large or very small numbers in one concise number so that it's more convenient to see what you're talking about. All right, so how are the numbers written? Well, they consist of two parts. The first part is a number between 1 and 10, but not equal to 10. In other words, you want to put the decimal after the first non-zero digit. So between 1 and 10, if it was 10, then you could move the decimal over one more place and you could get 1. So between 1 and 10, but not equal to 10. And then n, little n, is an exponent. It can be a positive or negative whole number. Again, m is written with the decimal in the standard position, which is to the right of the first non-zero digit. And then the exponent actually represents how many times you had to multiply or divide by 10. So, for example, 2,530. You can think of it as 2.530 times 10 times 10 times 10. Or 2.530 times 1,000, which is 10 times 10 times 10. So we can rewrite it like that. So you're literally saying, okay, take 2.530 and multiply it by 10 3 times. So it's just another way of writing it. Notice that I moved the decimal, which is after the 0, to the left 3 times. And so each time I move it to the left, what I'm doing is separating the times 10 out. So if I move it over 3 places to the left, then I have to multiply it by 10 to the third. A number that's smaller than 0 can be written, so you can see 0.000367 can be thought of as 3.67 divided by 10 divided by 10 divided by 10 divided by 10, or in other words, times 1 over 10 times 1 over 10 times 1 over 10. And just for your information, if you have 1 over 10, that's the same as 10 to the negative 1. 10 to the negative 1 exponent is the same as 1 divided by 10. So again, notice that if we take 3.67 and we divide by 10 4 times, we get 0.000367. So we can also write it as 3.67 times 10 to the minus 4th, or in other words, 3.67 divided by 10 4 times. Keep in mind that if the exponent is positive, that indicates a really big number, and if the exponent is negative, it indicates a very small number, or a number less than 1. Sometimes it can be confusing because you're thinking, well, if I'm moving the decimal to the left, it's true, you're moving it to the left, which means that in order to compensate for moving it, you're going to have to multiply by 10. So that's why we're kind of pulling it out from each other, 2.53 and then times 10 times 10 times 10. Okay. So, again, notice that when the number is larger than 1, the decimal point has been moved to the left until it's in standard position. So, here you can see in this number, which is, let's see, 10 billion, 10 million. The original position is after the 0, and if we move it over 10 places to the left, we get 1.001 times 10 to the 10. So a positive n means a very large number. When the number is smaller than 1, the decimal place has to be moved to the right until it's in standard position. And so what we're doing is we're actually pulling out, to get back to the original position, we would have to divide by 10 7 times, and so, or multiply by 1 over 10 7 times. And so we move the decimal over to the right 7 times, and then we multiply 1.001 times 10 to the minus 7th. And if you get confused, just remember the negative exponent is for very small numbers. The positive exponent is for very large numbers. All right, there's a lot of different ways that calculators have you put scientific notation in. And make sure that you understand yours. Like I said, if you want to, if you're in my in class, you can ask me for help, or ask someone that you know for help, or you might find a YouTube video. I have posted a YouTube video a particular, I can't remember exactly which calculator it is, but you might look at that. It's in the video section of the Blackboard, and it can help you decide, or it may help you use your calculator. What you need to look for is the scientific notation symbol. So it's different on different calculators. Sometimes you'll see the capital E. Sometimes you'll see EXP. Sometimes you'll see a times 10x button, or I've seen it where it's a times 10n button, which means the same thing. And what if you press that button, and sometimes you'll have to press the second button first and then press the button to activate it. If you activate that button, what you're actually doing is putting in the times 10. So you don't actually want to hit times 10 as well. You just want to use this button. So for example, if you're trying to enter the number 2.3 times 10 to the minus 25th, you would enter the number 2.3, then press the button that activates the exponential mode. And so that's like putting in the times 10. And then all you have to do is put in the exponent. So 2.3 EE negative 25. And keep in mind, sometimes calculators, there's a few cheaper calculators that won't let you put a negative in before you put the number in. So if that's the case, put the 25 in and then the negative. Most calculators these days let you put the negative in first and then the number. So again, 2.3, then press the exponential mode, EE or EXP or times 10 to the n, whatever your calculator uses, and then hit negative 25. So you're not going to hit the 10 and you're not going to hit the times. And then you might see what your calculator looks like. Some calculators will write it in different. Some of them will write the number with the exponent as a small number. Sometimes they'll write the times 10 in there for you. You know, get familiar with your own calculator. So keep in mind that once you enter a number in this way, it's treated as a single number in your calculator. And so you don't have to worry about order of operations. You don't have to worry about putting in any other thing. It's one number. So again, some considerations: don't use the multiplication sign separately. When you're using the function EE or EXP, it is in the place of times 10. So don't hit times, don't hit 10. Just put the number in EE and then the exponent. And then make sure that when you are doing problems, homework problems or something like that, when you look for the answer on the calculator, make sure and look carefully to see if it has an exponent. For example, you might be working very quickly and your answer might be 6.2 times 10 to the minus 7th, and you may be reading your calculator. It may say something like 6.25, 2, 3, 4, 5, 6, 7, and then way over in the far side it'll have E07 or negative 07, and you might not notice it. So just be careful about that. Know what your calculator looks like. Know how you how an exponential number looks on your calculator. Obviously 6.2 and 6.2 times 10 to the minus 7th are not at all the same. 6.2 times 10 to the minus 7th is 0.00000062, way smaller. And again, just to keep in mind, a positive exponent is always a very large number, greater than 1, and a negative exponent indicates a small number, less than 1. So if you're doing multiplications of numbers in scientific notation, it's easy to do it on the calculator if you use the scientific notation function. Here I've gone through what does multiplication of number in scientific notation look like if you were doing it by hand. You can see that what you need to do is multiply the m values first. So 3 times 4 gives me 12. And then exponents are added. When you multiply two numbers together, the exponents are added. So in this case, 10 to the 8th and 10 to the times 10 to the minus 2 is the same as 10 to the 8 plus a negative 2, or 6. So the answer to 3.0 times 10 to the 8th times 4.0 times 10 to the minus 2 is 12 times 10 to the 6th. However, that's not standard scientific notation, so you're going to have to move the decimal over 1 to the left, in which case you have to increase the number on the right to 7. So 1.2 times 10 to the 7th. Gives you the answer. We're not going to be doing a whole lot of these type of calculations, but I just want you to be familiar with it. Of course, if you put it in your calculator, 3EE8 times 4EE negative 2, you should get the correct answer. Sometimes your calculators may be really funny and they may end up giving you 0.000. I'm sorry, in this case it would be, this might give you the number 1200000, in which case you'd have to put it in scientific notation. And then some calculators have a scientific notation function that you can turn on, and then your numbers will always be in scientific notation, and then you can turn it off again. So get familiar with your calculator. All right, if you're dividing numbers in scientific notation, basically you're dividing the first two numbers. So in this case, you're dividing the 3 and the 4 to give us 0.75, and then you're subtracting the exponent. So it would be times 10 to the 8 minus a negative 2, or 10. So the answer would be 0.75 times 10 to the 10th. But because the decimal is not in the standard position, we have to move it to the right one, and so we have to decrease the exponent by 1. So we're not going to be doing a whole lot of calculations with two different scientific notations. Usually you just have one in a calculation. So don't get too stressed about this, but make sure that you can at least put these numbers into your calculator and recognize them when you see them in your calculator. All right, here's just some examples that you might want to try. And what I wanted to do was point out to you that a lot of students make this one particular mistake. If you have more than two numbers in the denominator and you're putting it into your calculator, you want to make sure and use the divided function every time you have something in the denominator. So if you look at the bottom left-hand problem, if I were putting that in my calculator, I would type in 963 times 1.03 divided by 0.555, and then I would hit divided by again for 12, not multiply, because order of operations would end up taking that. It would take the answer from 963 times 1.03 divided by 0.555, and then it would multiply it by 412 if you hit multiplication. But so if it's in the denominator, you want to make sure and hit divided by. If you're still a little bit confused about that, what I would recommend is taking the 963 times 1.03 and multiplying that out and coming up with an answer, and then multiplying 0.555 times 412 and coming up with an answer, and then taking the numerator divided by the denominator after you've done all the other math, and then you'll get the right answer. But if you just want to put it in directly, every time something's in the denominator, you hit divided by. Even if you see that multiplication sign, that's sort of the two numbers have to be multiplied first before you divide them. All right, so you might want to practice these and make sure you get the right answer. So let me introduce you to the metric system. The metric system is a far superior system because it's all determined by powers of 10. And so for we can have the basic unit, which is like grams for something for weight, liters for volume, meters for distance. You can use seconds for time. If you want to use some kind of measure of energy, you could use calories, or like a byte. When you're talking about computer storage system, a byte can be a basic unit. And then you use a prefix to put together with it to indicate what power of 10 you're talking about. So for example, if you have a kilometer or a kilometer, that means 1,000 meters. If you're talking about a milliliter, that means 10 to the minus 3 liters, or 1/1000th of a liter. And so here are the units that we use. Tera, which is basically a trillion, 10 to the 12th. Giga, which is 10 to the 9th. We've heard of gigabytes. That means there's a billion bytes in a gigabyte. Mega, which is a capital M. Kilo, which is a lowercase k. Hecto, lowercase h. Deca is a capital D. Deci, which is 1/10, is the lowercase d. Centi, which is a lowercase c. Milli, which is a little m. Micro, usually we use that Greek symbol mu, which is that sort of curly QM, or some people think it's a U, or you could also use MC, either one. Nano, which is N, and pico, which is P. Notice that I've starred the ones that we commonly use, and actually double starred the ones that we use quite a bit. Kilo, centi, milli, deci sometimes. We do use micro. We use nano actually in chemistry quite a bit, but we probably won't be using it much in this class. So let's see how we can use them. So here are just some of the common measures that you might see if we put the prefix and the unit together. So a kilometer is the same as 1,000 meters, or a kilometer, you could say. A milliliter is 0.001 liters. You can multiply both sides by 1,000, and you could also say that you have 1,000 milliliters in a liter. Either way, they're equivalent to each other. A milligram would have 0.001 grams. A nanosecond has 0.000000001 second, or 10 to the minus 9th seconds. A centimeter is 0.01 meters. And like I said, if you multiply both sides by 100, you could also get that 100 centimeters is a meter, or 1,000 millimeters is a meter, or 1,000,000 microliters is a liter, or you could also have 1,000,000 micrometers is a meter. So the base unit doesn't matter. The prefix is what changes. And so here's just some examples. 5.5 kilometers just means 5.5 times 1,000, or 5,500 meters. So you could say 5.5 kilometers or 5,500 meters. They mean the same thing. 23 milligrams really means 23 times 0.001 grams, or 0.023 grams. 99 nanoseconds would be 99 times 10 to the minus 9th seconds, which would end up being 9.9 times 10 to the minus 8th seconds. 32 gigabytes means literally 32 times 1 billion bytes, or 32 billion bytes. The metric ladder is something that is useful since every time you multiply by 1,000, you're moving the decimal place to the right, and anytime you divide by 1,000, you're moving the decimal place to the left. You can actually convert from one metric unit to another by using this ladder. So how do you do it? You can see that if you're moving from one unit to the right to get to another unit, what you're having to do is move the decimal point to the right, which means you're multiplying. If you're going from one unit to another unit to the left, you have to move the decimal point to the left, which means you're dividing by 10. You can see there that the basic unit would be meter or liter or gram or second, or whatever the basic unit is, and then moving it to the right once would be converting it to deci, moving it twice would be converting it to centi, moving it 3 times would be milli. We don't have a name for those two between milli and micro, because milli's 10 to the minus 3 and micro's 10 to the minus 6. And then actually I don't have enough room to do it, but if you moved 3 more to the right, you would have nano, and 3 more to the right, you would have pico. Going to the left, we have deca, hecto, and then kilo. And then the same thing, if you go 3 more to the left, you'll have mega. 3 more to the left of that will be, 3 more to the left would be giga. Okay, so let's just do an example. If I have 4 kilometers and I want to convert that to meters, what do? Well, I start at kilometers, which you can see is up in the left-hand corner. And so I have 4. What do I need to get to the basic unit of meter? I have to move the decimal place to the right 3 places. So I would have 4,000 meters. What if I had 10 milliliters and I wanted to change that to centiliters? Well, so if I had 10 milliliters, to move the decimal place 1 to the left to get to centi, so that would be 1 milliliter, centiliter. 1 centiliter is the same as 10 milliliters. If I wanted to convert from kilometers to millimeters, so here's some more examples. Convert 53 milligrams to grams. Well, the decimal place, if you don't see it, of course, it's at the end of the number. So you can see that it's after the 3. To go from milligrams to grams, I have to move the decimal place over 3 places to the left. So it ends up being 0.053 grams. If I want to convert kilometers to centimeters, that means I have to move it over 5 places to the right. So I take the decimal after the 3 and move it over twice. We'll put it after the 5, and then I need 3 more O's as placeholders, and so there's 325,000 centimeters in a kilometer. Temperature scales. The 3 most commonly used temperature scales are the Fahrenheit, Celsius, and Kelvin scales. The Celsius, Fahrenheit, of course, is what we use every day. What you can see is that there's 180 degrees between the freezing point of water and the boiling point of water, 32 to 212. The Celsius scale is a little bit more, a little bit superior, because we go from 0 degrees freezing point to 100 degrees, so that's a difference of 100 degrees. So the Celsius degree and the Fahrenheit degree are not the same size. The Kelvin scale is what we call an absolute scale, because if you think about the Celsius scale, if you're at 0 degrees Celsius, that doesn't mean there's no temperature at all. There are no heat at all. We can exist at 0 degrees Celsius. Water freezes at 0 degrees Celsius, but it doesn't mean an absence of heat. So actually the Kelvin scale is absolute, because if you get to 0 Kelvin, that is an absolute 0. You can't get lower than that. And so an absolute scale means there's nothing lower than 0. So 0 means 0. Weight is an absolute scale. If I weigh a pin and maybe it weighs a half of a pound or something like that, if I put nothing on the scale, it would weigh nothing. So that's an absolute scale. Whereas 0 degrees Celsius is not really 0. You can get negative 30 degrees or whatever. So the Kelvin scale is an absolute scale, because 0 means 0. So how can we convert between these? If you want to convert from Fahrenheit to Celsius, use this. First you have to take the Fahrenheit, subtract 32, and divide by 1.8. If we want to convert from Celsius to Fahrenheit, what we have to do is take the Celsius, multiply by 1.8, and then add 32. To get from Celsius to Kelvin, you just take the Celsius temperature and add 273. Because absolute 0 is actually negative 273 Celsius. And if you want to go from Kelvin to Celsius, you take the Kelvin and subtract 273. So let's do an example. If it's 75 degrees right now in the room where you are, what does that mean in terms of Celsius? Well, if we take the Fahrenheit, first we do is subtract 32 to get 43, and then divide by 1.8. That will give us 24 degrees Celsius. So 75 Fahrenheit is the same as 24 degrees Celsius. what would that be in Kelvin? What is 75 degrees Fahrenheit in Kelvin? Well, if it's 24 degrees Celsius, we add 273 to it and we get 297 Kelvin. So that's how you can convert. This is the end of this unit, this narrated, and then the second half of chapter of unit 2 will be on the next narrated slide presentation.